Good morning from Dhaka, Bangladesh. This is 13th lecture of AS and A-level chemistry lecture series. And we will discuss oxidation reduction reactions in this lecture. In AS and A-level syllabus, we see this chapter as Redox 1 and Redox 2 respectively. So this reaction is a very important reaction, and it is taken into consideration all branches of chemistry, as example, inorganic, physical, organic, analytical chemistry. So what is redox reactions? We have many different types of chemical reactions. One of the very important reaction is redox reaction. Oxidation and reduction. So oxidation is gain of oxygen. Example, magnesium metal, and if we react with oxygen, magnesium metal gets oxidized. Similarly, reduction is loss of oxygen. If we take copper monoxide and react with hydrogen, we get copper metal and water. This is reduction. Well, this above copper oxide and hydrogen reaction, we can see copper oxide is reduced to copper metal. However, hydrogen gain oxygen and becomes water. So hydrogen is oxidized here. Therefore, oxidation and reduction takes place simultaneously. And this is why we call this type of reaction redox reactions. I take an example here. We know we can extract metal from where? From its ore. Let's say we want to extract iron metal. Iron ore is iron oxide, which is naturally occurring. And we have to remove oxygen from the iron ore, and then we get metal iron. When this metal iron is left in the air, we get corrosion. What happens then? Metal iron oxidized and even corrosion, and which is called rust. So in this one, we can see that both oxidation and reductions are taking place simultaneously. Well, this is not the only definition of oxidation and reductions. There are other ways of defining oxidation and reduction. For example, we say for oxidation, removal of oxygen. And here, oxidation is removal of hydrogen also. We can say removal of hydrogen, and reduction is addition of hydrogen. These sort of reactions we often see in organic chemistry. Another way of defining oxidation reduction is oxidation is loss of electrons and reduction is gain of electrons. To remember it, it's very interesting to see. Oxidation, here you see, oxidation O-E-I-L, oil, reduction R-I-G, rig, oil rig. If we remember this, we immediately can define oxidation reduction very easily. Another way to say about oxidation reduction, we can also look to electron transfer and change in oxidation number. That can also tell us which one is oxidized and which one is reduced. So there are many ways of defining oxidation and reduction. Well, I said in the beginning, this is a very important reaction. An example, photosynthesis, which provides entire planet's food. And this is photosynthesis is definitely an oxidation reduction reaction. Similarly, respiration, which keeps us alive. This is also an oxidation reduction reaction. Well, with this definition, in the following example, let's say taking reaction 1 and 2, which one is oxidized from here? We can immediately note that hydrogen getting oxygen from lead oxide is oxidized. Similarly, carbon monoxide, getting oxygen from silver oxide, being oxidized to carbon dioxide. Similarly, we take another two examples and show which one is reduced in these two reactions. You see, iodine oxide is being reduced to iodine, metal iodine. Sulfur dioxide is being reduced to sulfur. So it is very easy if we take into consideration all type of definitions of oxidation and reductions to define this. Well, you see, we have to also find the application of this. A simple application, very simple application, is this is a ship hull which is made of iron, and this has to be protected because if it gets rust, then ship hull become I would say unused part. So what we are doing, we are having a metallic bar here, and that is magnesium metal bar. Magnesium easily oxidized in preference to iron. Therefore, this magnesium bar is called sacrificial protection to the ship's hull. This is being used in Navy ships, naval ships. What happens here, that iron is supposed to oxidize. We are getting in contact with water, but this magnesium bar, magnesium atom, protects it. And that is why it is called sacrificial protection. This one, sacrificial protection. Well, we go for oxidation number now. Well, we have to take into consideration, well, this could be a question of why magnesium bar gets oxidized before the ship's hull's iron. That could be explained in details when we go to advanced level of chemistry in A level. And there we know about electrode potential, and this will explain more easily with the help of electrode potential why magnesium gets oxidized before iron. Now we go for oxidation number. Oxidation number is a number. What is the number? Number of an atom or ion in a compound. And that number could be positive, negative, and even zero. So when we talk about oxidation number, we must include the sign, whether it is positive or negative or zero. So that will tell us which one is degree of oxidation is higher and which one's degree of reduction is higher. So more positive oxidation numbers of an atom or ion in a compound is more oxidized. Negative oxidation number means that it is less, more reduced. Okay, so we take, well, redox reaction. I talked about oxidation number. Now we have to follow some rule to assign oxidation number of atoms or ions in a compound. What are those rules? Those rules, any element uncombined, not combined with anything, elemental form, the oxidation number is zero. For example, sulfur 8, chlorine 2, zinc, these oxidation number is zero. Well, there are compounds and ions where atoms have fixed oxidation numbers. For example, group 1 elements, which we call sodium, potassium, rubidium, they have always +1 oxidation state. Group 2 elements, beryllium, calcium, magnesium, these are always +2 oxidation state. Fluorine is the only element which has got -1 oxidation state. Fluorine is having high electronegativity, highest electronegativity, and therefore it has got only one oxidation state, and that is -1. Hydrogen is plus oxidation state, but exception is there. When it reacts with metal hydrides, then hydrogen becomes -1 oxidation state. Oxygen is always -2, except peroxide, where it is -1, and in fluorine oxide, where it is +2. The oxidation number of monoatomic element in has got its charge is the oxidation number. For example, chloride ion, its charge is -1, and therefore its oxidation number is -1. Aluminium 3+, its charge is 3+, and therefore its oxidation number is +3. Another rule we have to follow to get the oxidation number of an atom or ion, the sum of the oxidation number of atoms in a compound must be G. Again, the sum of oxidation number of an ion is equal to the charge of ion. Neither compound or ion, more electronegative element is having negative oxidation number, more electronegative element. So here is an example of few compounds from where we can find out the oxidation number of the bold atom. I take this one first, G. We want to know the oxidation number of calcium here. We know this is a neutral compound. Sum of the oxidation number of all atoms should be 0. We know calcium is a group 2 elements, so it has got oxidation number +2, must be +2. Oxygen, it is not in peroxide or fluorine oxide, so it must have -2. So 3 oxygen is here, so 3 into -2, -6, and then we have +2, so therefore -4 should be the oxidation number of carbon. Similarly, we can find out oxidation number of any of these atoms. So for example, we take this one, we know oxidation number of oxygen is -2, so therefore we have 5 oxidation atom, so it is -10, and here we have phosphorus, 2 phosphorus atom, so it must be +5 to neutralize these 2 charge. Similarly, we can find out any oxidation number of these bold atom. It's very easy to find out. Well, oxidation also, we can look into the change in oxidation number, and we can say which atom is oxidized and which atom is reduced. You see? So if we take a reaction, let's say we are taking this reaction, tin and nitric acid are getting product, tin oxides, nitrogen oxide, and water. We can look to the oxidation number, change in oxidation number. It is a metal, so its oxidation number is 0. When it reacts with nitric acid, the oxidation number of tin becomes +4. So tin is oxidized here. So change in oxidation number is +4, therefore tin is oxidized. We take nitrogen here, its oxidation number is 5. And we take nitrogen here, its oxidation number is 4. So change in oxidation number is -1, and therefore nitrogen is reduced here. If we take oxygen and hydrogen, we will see here oxygen, hydrogen, the change in oxidation number has no change in oxidation number. So therefore, hydrogen or oxygen atoms are neither oxidized or reduced in this reaction. Another one we can take, this question is this: deduce the change in oxidation number for the atoms or ions in the following equation. State if oxidation or reduction has taken place. Definitely oxidation reduction has been taken place, because change of oxidation number here in arsenic oxide coming up here, it's arsenic 5 oxide. So therefore change of oxidation number is 2. Here it is 0, and iodine is 0, and here iodine is -1. So changes of oxidation number is -1. Therefore, in this reaction, this atom is oxidized and this atom is reduced. This atom is reduced. Well, we have been looking to oxidation reduction reactions. We have to identify oxidizing agent and reducing agent. What is oxidizing agent and what is reducing agent? Oxidizing agent is also called oxidant. A substance which brings the oxidation number by removing electron from another atom if a reaction, any substance changing the oxidation number of another atom is called oxidizing agent. How change it is? It should be increased in oxidation number of another atom. Oxidizing agent will increase the oxidation number of another atom. So typical oxidizing agent is oxygen, chlorine, potassium permanganate. The oxidizing agent itself will decrease its decrease in oxidation number itself. So for example, we take potassium permanganate here and iron 2 in an acidic media. So we see that manganese atom has reduced the oxidation number changing, and therefore this is oxidizing agent. And here iron 2 has been oxidized to 3, and this is a reducing agent. So reducing agent we also call reductant, the same thing, donating electrons to another atom. Remember, it is donating electrons to another atom. Okay, so a reducing agent decreases the oxidation number of another atom on that. So similarly, typical reducing agent is hydrogen, potassium iodide, or metals, reactive metals, such as tin, zinc, aluminum, etc. We have an example here, oxidizing agent and reducing agent. To find oxidizing agent is this one, manganate ion, and reducing agent is this one, iron 2, in this reaction. Mind it, it depends on the media. We have to have acidic medium to get this reaction. We'll finish with these slides, this lecture, and it will be continued in next lecture. We are talking about oxidizing agent and reducing agent. There are substances which can act as both oxidizing agent and reducing agent, and that depends on the media as well as the temperature. So hydrogen peroxide is a substance which acts as a reducing agent and oxidizing agent depending on the media. As oxidizing agent, when we react this in acidic media, it is oxidizing agent. If we react this in alkaline media, this is alkaline media. This is acidic media symbol. This is alkaline media. If we react this in alkaline media, then it acts as a reducing agent. So there are few chemical agents, reagents, where depending on the media of the reaction and temperature, this can be an oxidizing agent as well as a reducing agent. We were talking about redox reactions, but balancing of redox reaction is also very important. So there are two methods of balancing of our redox reaction. One is oxidation number change method, and another is half reactions method. We will discuss this in next lecture. Up to this, today's lecture, we finish, and thank you very much.